Bismillahirrahmanirrahim. Dear students of class 12th, we will study properties of magnetic materials. As we know, all magnet substances magnetic domains, and hence they all possess magnetic properties, or they can be magnetized. Not just only iron and steel, but we can magnetize any substance. On their magnetic behavior, on the basis of the magnetic behavior, Faraday divided magnetic substance into three categories called diamagnetic materials, paramagnetic materials, and ferromagnetic materials. Diamagnetic materials, they are feebly, when they are put in a magnetic field, they are feebly or weakly magnetized in the direction opposite the field. And paramagnetic, they are magnetized again weakly or feebly, but in the direction of the field, and paramagnets are strongly magnetized. Now we have different examples. As you know, for ferromagnets we have iron, cobalt, nickel, and for diamagnet we have copper. Examples of the copper, zinc, bismuth, silver, gold, lead, glass, marble, water, helium, argon, sodium, chloride. They are diamagnetic, and paramagnetic examples are aluminum, antimony, platinum, copper chloride, manganese, chromium, and oxygen. They are the examples of paramagnetic material. And ferromagnetic, we are very much similar with them. They are strongly magnetized and strongly attracted by the fields. They are iron, nickel, steel, cobalt, and now properties of diamagnetic materials. And for paramagnetic, they are opposite to the diamagnetic. So you can see while studying the magnet properties and diamagnetic, you automatically learn about the properties of. First, these magnetic feebly magnetized in the direction opposed to that of the magnetizing field, and when they are put near a magnet, these diamagnetic are feebly repelled by a magnet, whereas paramagnets are attracted feebly, and ferromagnetic are strongly attracted. And second, diamagnetic substances, there is no net magnetic dipole, because we have small or molecular dipoles, magnetic dipoles within a substance. All substances, they are on the electronic theory. सब में होता है कि इसके अंदर एक छोटे माइक्रो लेवल के मैग्नेट होते हैं और मैग्नेटिक डाइपोल होते हैं, and total magnetic moment is zero. Net magnetic dipole moment is zero in case of diamagnetic material, and in case of paramagnet there is some, but in case of ferromagnet there is a large value of net. So diamagnetic substance, when substance inside a magnetic field aligns at right angles, that why because it is repelled by the, again it moves, diamagnetic material moves away from the strong field, so it aligns at the right angles, not in the direction of the magnetic field, north south. If the diamagnetic liquid is put in a watch glass and placed over the two closely spaced pole pieces, it suffers a slight depression in the middle, and if the pole pieces are moved away, the pressure rises up in the middle. It is because the substance moves from the strong part of the field to the weaker part. In first case, that when pole pieces are very near, then the field is strong at the middle, so there is depression. liquid moves, diamagnet moves away. And in the second case, the field becomes weaker, hence there is a hump, there is a hump or there is rise in the depression at the middle. The intensity of magnetism, that's I, has a small negative value for diamagnetic, and the magnetic field lines they avoid to pass through the diamagnetic substance when placed in a magnetic field, that is, they are less dense within the magnetic field. The magnetic susceptibility becomes small, as we know that this susceptibility is I by H. And relative permittivity is also less than 1. These substances do not obey the Curie's law, as susceptibility does not change with, that is, susceptibility does not change with the temperature. When the diamagnetic substance is placed in the magnetic field, the magnetic induction B, or flux, magnetic flux density, in the magnetic substance is less than that in the vacuum. As for relation, B is equal to mu naught H plus I. I is negative, so B is less than mu H, mu naught H. Mu naught H is magnetic induction in the vacuum. Magnetic induction in the vacuum. As for the paramagnetics, we will see that they follow the Curie's law, that is, susceptibility is inversely proportional to temperature. That is, when we increase susceptibility, this paramagnetism decreases. And similarly, when the liquid is placed between pole pieces, there is a hump in the middle, and when pole pieces are taken away, there is a depression in the middle. And when the pole is magnetic, it is in a suspended between the in the magnetic field. It aligns in the direction of the field. The value is small, magnetized intensity is positive, hence relative permittivity and susceptibility, they are positive and slightly greater than 1. For ferromagnet it is large. And relative permeability of ferromagnet is slightly greater than 1. And susceptibility is also positive and is a small positive, has a small and positive value. And they obey Curie's law, that is, the susceptibility of the paramagnetic substance is inversely proportional to its absolute temperature. In case of ferromagnetics, as I have already told, that they are strongly attracted by magnet. When they are suspended, they quickly align in the direction of the magnetic field. Ferromagnets move from weaker part of the magnetic field to the strong, and ferromagnetic liquid is not found in the liquid as gas. However, when the ferromagnet is placed inside the magnetic field lines become slightly dense in the ferromagnetic substance. For ferromagnetic intensity of magnetization has a large positive value, as susceptibility has also a large positive value, and the relative permeability of ferromagnetism is extremely large as compared to I. When the ferromagnetic substance is placed inside the magnetic field, the magnetic flux density, that is B, is much larger than that in the vacuum. Thank you. That was about properties of magnetic substance.